Alrighty, so today I'm talking about reaction order graphs. We've talked a lot about zero order, first order, and second order. Um, and we looked at the table, but you can also take the table and graph it on a computer or your graphing calculator. I would suggest on a computer that's a lot easier using Google Sheets. But they're going to give these general graphs depending on what order it is. So we're going to have the zero order here. So zero order, first, and the second order. So on a zero order reaction, it's just going to be the concentration of your thing over time, and then the concentration of your reactant will decrease linearly over time. For a first order reaction, you're actually going to have to take the natural log of the concentration, and that's going to equal time. And this will also give you a downward facing line, because if we graphed the concentration over time of a first order reaction, it's going to look like this. Determining rate and reaction order. Talked about zero order, the concentration over time is going to decrease linear. First order, the natural log of the concentration is going to decrease linearly over time. And then if we were to graph a first order reaction with concentration over time, it would create this logarithmic looking graph. And then for second order, it's going to be the inverse. So this would be 1 over the concentration of A, but I like to write that as A raised to the negative first power and over time, and this will result in an upward linear graph. And if we were to graph second order time versus concentration of A, it would decrease even faster, like so. So those are the reaction graphs, but if you're trying to determine rate off of a graph, you want to graph the concentration over time, the logarithmic over time, or the natural log over time, and the inverse over time, and which one of those is linear, even faintly. Non-linear means not linear. It should be straight linear. And then these lend into some equations I will get into. For the zero order, it's just going to be the concentration of A equals the negative kT plus the concentration of A initially. And this kT has to be negative because this is basically, this is y equals mx plus b, y equals mx plus b. So our slope-intercept here of the y is up here. We have a negative slope of k, and then as time increases, that's our x, and we get our concentration. For the first order reactions, it's going to be the natural log of A equals negative kT plus the initial concentration, the natural log of the initial concentration. So very similar setup to this one over here, only we're using natural logs. And then for the rate one, it is positive, so kT is going to be positive plus the inverse of the concentration of A equals initial. This one's initial. And then concentration of A, negative 1 as well. So they all function off this y equals mx plus b format, but these are the graphs. And so by knowing a time and knowing your concentrations and knowing what order it is, you can get k. I hope that was helpful.